right, now, what we're going to end up doing is particles to mass, or mass to particles. So it's going to kind of go both ways in this case. Now, if we took a look at over here on the board, which we can't see on our screen, there's no straight line shot between mass and particles or particles and mass. If you look over here, mass and particles, there's no line. But we can get there. You'd have to go mass to moles to particles. Or you go particles to moles to mass. And if you take a look at the chart that's here, mass to moles to particles, or particles to moles to mass. So that's why the chart was built this way, so you actually have defined paths that are going to tell you what you need to convert by, and convert with, and convert how to get to where you need to get. Now, where do we always go through? What's the one thing we always have to go through? Moles. So we're always going through moles. So everything gets converted to moles. Now, let's say we have an example. And this example says you have 2.31 times 10 to the 24th atoms of, let's say, oxygen. How many grams and moles of oxygen do you have? So we have atoms. So we're given, what are we given? We're given atoms, which is our particles. And what do we want? We want moles, and we want grams. So we want two things. We want grams, and we want moles. So we're given that amount. Now, here's the unit analysis. The unit analysis, I'm going to draw it out a little bit because I'm going to end up putting the numbers in here. What are we given? We're given atoms. Now, what's the conversion factor? Because we have atoms, which is particles. Particles, we have to go to moles first. It says we have to go to moles. So how do we go to moles? Well, I want to get rid of atoms, and I want to get to moles. And so, at this point, the atoms will end up dividing themselves out, and I'm left with moles. So now, where do I want to get to from moles? To grams. So I want to go moles to grams. I don't need to put a GR there. And then the moles end up dividing themselves out. Now this part right here is the given. This part right here is what we did yesterday, particle to mole conversion, which is going to use Avogadro's constant, which is a 6.022 times 10 to the 23rd. So it's going to use that. Now, this guy right here is mole to mass conversion, which is going to end up using molar mass. So I'm going to have to know molar mass. Now, what element are we dealing with here? Oxygen. So oxygen, what's the molar mass of oxygen? Well, we got to jump into the periodic table. Here's oxygen. What's the molar mass? 16.00. All right, so I know 16.00 grams per mole this is my molar mass. Because when we're dealing with molar mass, it's going to be mass per moles. And now we can go through and put in our numbers. What are the number of atoms that we were given? 2.31 times 10 to the 24th. Now, when we're converting moles to atoms, how many moles are there in the conversion factor? How many moles are there in all conversion factors? There's 1. How many atoms are in the conversion factor? 6.022 times 10 to the 23rd atoms. Yeah, and then we'll end up dividing that. But now let's go to grams per mole. That's molar mass. So how many moles are there again? 1. That's the nice thing. Outside of if you're given moles, the number of moles in all the conversion is going to be 1. So, how many grams of oxygen are in 1 mole of oxygen? 16.00. And that's your molar mass. Now, I'm going to not define something because it's not really a definition. But if you do this one first, I'm going to call this an off-ramp. If I ignore this part right here, if I ignore it right here, what's my answer going to be in? Moles. Isn't that one of the things we want to do? Yeah. So, even though we've set this problem up to get to our final answer in grams, even though we set it up, what we want to do is, in this second conversion, in this first conversion, we can actually get the answers in moles. So this off-ramp after the first conversion will give us the number of moles that we have. And then we can go to the number of grams. So if we do the calculations, 2.31 times 10 to the 24th, then I'm going to divide that by 6.022 EE23. That's going to give me 3.8359 times 10 to the 0. And that's going to give me the number of moles. So I know the number of moles now. So the number of moles is going to be equal to we can just go to 2 decimal places. So 3.84. Moles of oxygen. That's how many moles of oxygen we have. Now, don't clear out the calculator. Because in the calculator we have the exact answer from the first set. Now, I took care of this first part. We ended up with the number of moles, 3.84 moles of oxygen. Now, how am I going to figure out the number of grams? I have 16.00 in the top. Do we multiply or divide? If the number's in the top, do we multiply or divide? We multiply. So just multiply that number by 16.00. And now you don't have to type in the 0.00 because we know that 0.00 doesn't really do anything for it. But I do it anyway because that's just how I am. And if we keep it at 2 decimal places, which is fine, we get 6.14. That 3, that 7 turns that into a 4, times 10 to the 1 grams. If we would have just multiplied this by 10, if you put 61.4 grams, I would have been okay with it. But to keep it at 2 decimal places, keep things in scientific notation. And yeah, I know it's not 100% with the sig figs and all that, but for right now, if we just go to 2 decimal places while we're fighting through this and learning how to do this process, we'll deal with sig figs a little bit later. This process, we still get that answer from there. Now again, it's absolutely essential to set up. Absolutely essential to set up the unit analysis. If you go mass to particles, you're going to end up with this. It's going to go grams, and then you're going to go grams to moles. And then you're going to go moles to particles. That's your conversion. Because in this, the grams divide out, the moles divide out, you're left with particles. If you're going to go particles to mass, it's going to end up with this. Particles, sorry, with that issue there. Then we'll put particles here. Particles per mole, and then mole per gram. And then these two divide each other out, and you're left with whatever your answer is in grams. Like this answer is going to be in particles. So these are the conversion factors that you'll end up dealing with.